I've developed an entirely automated embedded system that makes use of both digital and analog outputs and inputs. The PIR performs the role of a digital input, while the servo motor performs the role of an analog input. Even though the servo motor is a digital device, analog input is used to set specific angles for control. Digital output LED is used to indicate whether the system is on or off. Lastly, a serial USB cable transmits a timestamp to a computer's CSV file, carrying out analog output function. Unfortunately, my microbit didn't have enough power supply to power the PIR, so I had to switch to an Arduino. All sensors and outputs have been kept and perform their intended functions in the system. A USB cable is used to transmit data. The Python script processes data from the serial port. Next, the data from a serial port is written to a CSV file with the name test2 and output to the console as well. Python code utilizes pandas and matplotlib to analyze data from a CSV file test2.csv. It reads the file, counts the occurrences of each timestamp using pandas and build function .count, identifies the most frequent timestamp using pandas and build function idxmax, and then visualizes the frequency distribution of timestamps using a bar plot, highlighting the most frequent timestamp with a red dashed line. This graph gives clear understanding of when the bin is the busiest and when it should be cleaned to maintain high levels of hygiene and thus high level of well-being. I used Python to create a computer model for well-being. It is based on the data that was generated by function generateData on the screen. The dataset contains multiple descriptive arguments, such as sleep hours being integer type of data and calories level being float type of data. After the generation, values are validated through if questions. If the data is in correct format, then they are written to a CSV file. My model answers three what-if questions. The first question is what if the user sleeps for a short period of time, exercises infrequently, and consumes few calories. Second question, what happens to the mood if the user sleeps a lot, exercises a lot, and consumes a lot of calories? The two values for predicted mood are then compared using two bar charts. My third question is, what happens if the user has peak values for two parameters but low values for the remaining one? This condition is contrasted with another, in which the user has average values for all parameters. Which conditions are better for the mood? The predicted mood values are contrasted in bar chart format to answer these what-if questions. Overall, this computer-based model allows user to get better understanding of how his sleep, exercise, and calorie intake influence his mood, and how he should balance those to achieve the highest mood level. My unit testing contains three main tests. The first takes place in function test generate data. It verifies that exactly 365 rows of data and the proper headers are produced in a CSV file by generate data function. If the statement is true, the test passes. The second test occurs in function linear regression model. This test determines whether the linear regression model with generated data does reasonably well. After reading the generated CSV file, it divides the data into training and testing sets. Uses the training data to train a linear regression model, and then uses mean squared error MSE to assess the model's performance. If the MSE is 40 or less, the test passes because the model's accuracy falls with a reasonable range. The third test is enclosed in unit testing function test_predict_mood. Using randomly chosen data points from generated CSV file, this test determines whether the predict_mood function correctly predicts mood level. It compares actual mood level to the predicted. If the value is inside the tolerant range, the test passes. The results of unit testing were tabulated, as well as the results of black box and white box testing. Test tables serve as documentation for the testing process, laying out the various scenarios considered during development and validation. They help me to understand the scope and coverage of testing efforts. Furthermore, test tables help me to improve traceability, allowing to trace the resolution identified issues back to individual test cases.